What is up, YouTube? And welcome to another video. Now, since DevOps have become such a popular thing nowadays, I thought that I'd share something really special with you guys. Now, I've been in the DevOps position for many years now, and sometimes I just think to myself, I wish I knew some of these things sooner. So today I'm going to share with you my top 3 tips of things that I wish I knew when I started my career many years ago. So hopefully this will help fast track your career as a DevOps engineer. So without further ado, let's go. Being biased about certain technologies is okay, but when you have tunnel vision focus on a certain tech stack, it's not going to help you or your team. Now, I have my own biased opinions about technologies, but knowing and realizing the strength and weaknesses of these technologies is a massive superpower and can really help empower your DevOps career when you make decisions. I want to take programming languages as a specific example here. Having a fixation on a programming language just because you have many years of experience in that language can really hinder your ability to solve problems efficiently. It's a powerful skill to be able to pick up any programming language that can deal with the problem at hand. Some example for this is like Python. If you have like a large CSV file that represents a data structure that you want to do calculations on, Python is probably one of the most efficient languages that will deal with that data because it has such a vast variety of libraries available. If you want to write a command line program and something really lightweight, you can look at a language like Golang. Golang is really good because it's statically compiled, doesn't have any dependencies on a file system. You can really build like lightweight applications using Go. Another example is if you have like a traditional monolithic .NET workload, you might want to take a look at .NET Core because it's portable between operating systems, and you can also slice up your workloads and develop microservices. Now, this is just an example of using programming languages as an example of biasness, but the same goes for dealing with when you're making decisions around operating system choices, different distributions, open source technology specifically. There's so much technology out there in the open source space. And the other one is also cloud provider solutions. If you have a tunnel vision focus on a specific cloud provider that you're biased about, that can really limit your ability to come up with alternatives and great solutions. Now let's talk about biasness a little bit more. Sometimes it helps to challenge the problem you're looking at by stepping back and looking at the problem with a wide angle lens. Also, rather than thinking about the implementation and the lines of code you're wanting to write, because having a fixation on that and being biased about the solution, how you're going to solve it, limits your ability to think about alternatives. As a person, it's normal to have biased opinions, but as a DevOps engineer, you have to remind yourself that you're going to be presented with a lot of problems different problems from developers and operational folks. So it is a really powerful superpower to have the ability to challenge these problems and come up with multiple solutions to get a better outcome. Now, when talking about understanding the fundamentals, one has to stop and think about the statement a little bit. A lot of the time people ask me, how do you learn new technology so fast? How do you keep up to date with new technologies when it keeps changing and new technologies come out on a day-to-day basis? The way I do it is I learn about the underlying fundamentals of a technology rather than how to use the technology and how to apply the technology. Now let's take Docker as an example. Instead of just learning how to run a container, doing like the Docker run command, instead of doing that, rather dive into the Linux features that make containerization work and learn about those features. It makes it really easy then to understand how Docker works. And when you learn about these Linux features, you can then move on to technologies like Kubernetes that uses the same Linux kernel features to make Kubernetes work, and how Kubernetes automates these features. A lot of the features in containerization is just automation of Linux kernel features. So that's why understanding the lower level fundamentals helps you grasp the concept and exactly know how these interfaces to like Docker and Kubernetes actually work. Now let's talk about the fundamentals a little bit more. When we talk about Linux kernel features and learning about Linux kernel features in order to teach yourself containerization, you'll now have a fundamental understanding about how Docker works. And then if you take these Linux kernel features that you've learned a step further, you can actually apply the same concepts and really easily learn how Kubernetes uses these features to make Kubernetes is what it is. So this is just an example using Docker and Kubernetes as an example of studying the fundamentals of a technology, because now what you do is you actually fast track your learning even further, because when you learn about Linux features that make up Kubernetes, you start learning about networking, you start learning about load balancing, BPF, IP tables, and all these like Linux superpowers that will help you fast track your career in DevOps even further. So now by learning these other technologies, you start focusing on things like service meshes and sidecar patterns. And it really just makes it so much easier to learn about new technologies rather than learning how to apply them. Now, when people around you start talking about these technologies, because you've developed a vast fundamental understanding of the technology, it'll be easier for you to become part of the conversation. And then you basically learn how to put all the pieces of the puzzle together and paint a picture in your head about the technologies. And then you can focus on the gaps of the things you're missing rather than just focusing on how to use a technology. Now, technologies like Docker and Kubernetes and even some programming languages have a really simple interface for dealing with the technologies, and what they do is they actually hide the implementation details. Now that's good from a development experience point of view, but if you're trying to learn about a technology and have a fundamental understanding of it, it really hides the implementation details, and I would always encourage people to learn these lower level implementation, how things work, because that will fast track your learning experience and help you learn much faster when you understand these fundamentals. Now, when we talk about keeping it simple, this is probably something that you've heard over and over, and I constantly have to remind myself to keep things simple, because we live in a world where developers and operations constantly over-engineer, and technologies and cloud providers allow us to easily overspend. Now, cloud providers are absolutely loving us these days. Go on to Google, do yourself a favor and type cloud overspend, and then look at the hundreds of articles talking about the millions and trillions of dollars that people are just throwing away on cloud solutions. Now, some examples of cloud overspend and over-engineering is like when people invest thousands of dollars into like a big data SQL enterprise solution when they probably could have gotten away with storing JSON files on an S3 bucket, or going with like a very expensive monitoring solution and ingesting millions and gigabytes of data on like compute metrics, when at the end of the day they're only looking at CPU memory and disk IO. Another example I also have is when you want to write like a small web UI. People use like server-side code. They start writing ASP.NET, MVC, and writing backend code when all they could have done is write some simple HTML and JavaScript and thrown it onto a CDN and host it in like an Azure blob or an S3 bucket or something, and you don't really need a Kubernetes cluster for a simple UI. Sometimes we tunnel focus on a problem so much and we start thinking about the implementation details in our head, and that can be a really bad thing, especially when you're trying to keep things simple. You don't want to over-engineer a solution. Sometimes it helps to take a step back, looking at the problem with a wide-angle lens, and also ask you, is this actually the problem I want to solve? Sometimes these problems are self-inflicted, and talking to the right people in your organization, you actually figure out that it might not even be the problem you had to solve in the first place. You talk to the right people, you find out you can actually bend and transform the problem and actually come up with a much better solution. Now, as a DevOps engineer, you should also consider evaluating and learning about open source technology. Being able to have like a vast toolkit of open source solutions will really help you come up with the best alternatives and simple solutions rather than over-engineering. Now, technology like Docker makes it really simple to bring up and evaluate open source solutions, because you can just write one-liners to get them running and start trying them out. And I would encourage you to build your own personal website, whether it's a blog or whatever it is, and use open source technologies in your side projects that'll help you learn about them faster. Now, the other thing I want to talk about when keeping it simple and not over-engineering, is also a lot of DevOps folks either have a very strong developer background or they have a strong operational hardware and infrastructure background. Now, I would always recommend focusing on your weak points. If you're struggling to write code, maybe focus on that and learn how to code. If you're struggling to learn about hardware, maybe focus on that. Learn about infrastructure, learn about networks, load balancing, proxies. Part of being a DevOps engineer is having the ability to write code, build your own tools. So you can build your own command line interfaces that'll help like bridge the gaps between development and operational processes, and whether it's monitoring, performance, whatever it is, being able to write code and build your own tools sometimes is really easy to get a quick win, rather than going off and buying something off the shelf and where you could have just kept it simple. From the infrastructure side of things, being able to write code really helps. Let's say you want to deploy a proxy to load balance traffic. You could write a Python or a Golang or a Java application that will basically sit and help you update your proxy gracefully. So you could build an API around your proxy and drain traffic or whitelist IPs and do all these things automatically, rather than doing these things manually. So either way, knowing how to code and knowing about infrastructure will really help you keep things a lot more simpler and also prevent you from over-engineering. So just to summarize the three things that I spoke about, the one is biasness, second one is learning and understanding the fundamentals of a technology, and the third one is keep it simple. So hope you guys enjoyed it. Like and subscribe and let me know down in the comments what sort of videos you want to see in the future, and until next time, peace.